This is going to be the second video about solving 3x3 systems of equations. And what I want to do here is discuss a couple of systems of equations that might look a little bit different from what you're used to. So here's the first example. Over here I've got three equations. The first one is 2x plus y plus 2z equals 7. The second one is x minus 2y plus 2z equals negative 11. And the third one is 4x plus z equals 10. Now, at first you might be bothered by the fact that this third equation only has two variables in it. There's only an x and a y and no z. But if you think about it, when you solve 3x3 systems of equations, the first thing you try to do is get down to two equations with two unknowns. So here with this third equation, we've already got one equation with two unknowns. We've got an equation with just an x and a y and no z. So part of the work has been done for us. All we have to do now is make a second equation which doesn't have a y in it. And then we can go on from there like we're used to doing. So looking at the first two equations, what I would probably do is take the first equation, which has a positive y, and multiply that whole equation by 2, so that I could add it to the second equation, which has a negative 2y. Then I'd have a positive 2y and a negative 2y. They would cancel, and I'd get another equation with just x's and z's in it. From there on out, I treat this just like a normal 3x3 system of equations. And I'd work my way through it and get my values for x, y, and z. Okay? Here's another kind you might see. Here we've got, once again, three equations. The first equation is a plus b plus c equals 21. The second equation is 2a plus 3b plus 4c equals 64. And the third equation is just b equals 2a. Now, this is really nice, because what we're going to do is use this b equals 2a and do some substitution. In other words, I'm going to take the value for b, which is 2a, and plug that in wherever I have a b in the first or the second equations. So my first equation, a plus b plus c equals 21, I'm going to turn that into, that's going to become a plus, and instead of plus b, I'm going to write plus 2a, since b is the same as 2a, plus c equals 21. And I'm going to do the same process with the second equation. So I'm going to take this second one, 2a, and instead of plus 3b, I'm going to make it plus 3 times 2a. I'm just substituting 2a instead of the b. So I have a 2a over here, 3 times 2a, plus 4c equals 64. And now I'll combine like terms. So I'm going to take a plus 2a plus c equals 21. I'll combine the a and the 2a. That gives me 3a plus c equals 21. And I'll do the same process with the other equation. I've got 2a plus 3 times 2a. Well, 3 times 2a is 6a, plus 2a is 8a, plus 4c equals 64. So here I've got two equations with two unknowns. I'm going to solve these for one unknown, and then I'll continue the way I normally do with a 3x3 system of equations, finding out what the values are for each of my variables. Okay, so that's all there is to it. Take care. I'll see you the next time.